sensitivity, specificity, positive predictive value, and negative predictive value are measures of how good a diagnostic test is. They're also really frequently tested concepts, so you need to be comfortable calculating and interpreting them. Your best friend for this is a 2x2 table. Now, in a 2x2 table, disease status is always at the top, always. With positive on the left and negative on the right. And the test result will be on the side. Positive on top, negative on the bottom. All right, so in the disease positive column, these people have the disease no matter what. Regardless of what their test result says, we know that they have the disease. So if they have a positive test result, that test is correct. That is a true positive test result. TP for true positive. And if they get a negative test result, that's not correct. That test is wrong because we know that they have the disease. So this is a false negative. Similarly, for people who do not have the disease, that's the disease negative column. If they get a positive test result, even though they don't have the disease, the test is wrong. This is a false positive test result. And if they get a negative test, that test is correct because they don't have the disease. So this is a true negative test result. All right, we're going to use these to calculate sensitivity, specificity, positive predictive value, and negative predictive value. Let me just write these down. I'm going to write sensitivity down here at the bottom of the positive disease column. Specificity over here. By negative diseases, positive test result gets positive predictive value, and negative test result gets negative predictive value. And when we calculate these four equations, what I want you to remember is that true is going to go on the top and sum is going to go on the bottom. True on top, sum on the bottom. Let me show you what I mean. We'll start with sensitivity. Sensitivity, like I mentioned, is at the bottom of the positive disease column. So we are only looking at people who have the disease. And within this column, true goes on top. So the true value here is true positive. That's going to be our numerator. True on top, true positive. Our denominator is the sum. Sum goes on the bottom. That's true positive and false negative. Sensitive tests frequently get used as screening tests. This is because they rarely miss the disease. And in fact, a test that is perfectly sensitive will never miss the disease. Unfortunately, sensitivity doesn't tell us anything about the rate of false positives. And also, unfortunately, a lot of really sensitive tests have high rates of false positives. So an example here would be Pap smears screening for cervical cancer. And if you have a positive Pap smear, that means that cervical cancer is a possibility. That said, lots and lots of women have positive Pap smears, and then when you do colposcopy, they end up not having cervical cancer. These are false positive test results. This is where specificity is helpful. So specificity, remember we are looking at the disease negative column. We are looking at people who do not have the disease. And remember again, true is going to go on the top and the sum is going to go on the bottom. And so true within this column is true negative. And our sum is true negative plus false positive. Specific tests frequently get used to confirm a diagnosis after you have a positive screening test. And this is because specific tests give very few false positives. And in fact, a test that is perfectly specific will never give a false positive. So if a good example of a sensitive test is pap smear, then a good example of a specific test would be colposcopy. So to recap, sensitive tests are good because they don't miss the disease, and specific tests are good because they don't give false positives. Now, there is a mnemonic that gets used frequently that I find pretty confusing, but it gets used all the time, so we're just going to go over it really quickly. That's spin and snout. So let's start with snout. So for snout, you write SN for a sensitive test, SN, SN, and then you write N again for negative. So given a highly sensitive test, if negative, rules out the disease. So think again of the pap smear. If you have a pap smear that is negative, you can be pretty confident that you can rule out cervical cancer. Likewise for spin, SP for specificity, you write another P for positive. So given a highly specific test, if it's positive, rules in the disease. Thinking back to the colposcopy example, if you have a positive colposcopy, a positive specific test, you should probably be pretty concerned about cervical cancer. All right, let's move on to positive predictive value. Positive predictive value is at the end of the test positive row. So we're only looking at people who have tested positive. Remembering that true is going to go on top. The true value here is true positive. And the sum is going to be true positive and false positive. So how I like to think of positive predictive value is it's what your patient is going to want to know if they get a positive test result. So if I'm your patient and I get a positive test result, if I show up in your office, I'm going to want to know, given my positive test result, how likely is it that I actually have the disease? And another thing that you should know about positive predictive value, this is just one of those weird things that shows up on tests all the time for some reason. It's that with increasing disease prevalence, you get higher positive predictive value. And I just remember this because there are lots of P's here. All the P's are going in the same direction. High prevalence, high positive predictive value. Okay. Let's move on to negative predictive value. Negative predictive value is here at the end of the negative test result row. And remember that true goes on the top, so our true within this row is true negative. And our denominator is the sum, false negative and true negative. And similar to what positive predictive value is, it's if you get a negative test result, you want to know how likely is it that you actually are disease-free. All right, let's finish with a word on precision and accuracy. Precision in a diagnostic test requires that you are able to reproduce your results and that your results are consistent. So if I am an archer and I go to the archery range and I'm shooting at a bullseye, and if all of my arrows kind of go pretty close together around the same exact spot, really, really tight distribution, but none of them hit the bullseye, I'm precise, but I'm not accurate. Precision does not require that your test measures what it intends to measure. It just measures that you can repeat it really, really consistently. However, with accuracy, your test needs to measure what it says that it's measuring. So this would be if I went to the archery range and I was getting a lot of arrows in the bullseye, but not necessarily all in the bullseye. In fact, they can be pretty spread out and it'll still be called accurate. As long as it's centered on the bullseye and I'm getting them in the bullseye, that's considered accurate. It's just not precise because I'm not reproducing my results really well. So this is accurate. Now, ideally, you have a test that is both precise and accurate, and that would look like this, where you get a nice, tight distribution all in the bullseye. This is both precise and accurate. So that's precision and accuracy. Let's just summarize really quickly the sensitivity, specificity, positive predictive value, negative predictive value. Just remember that these are really important concepts and you definitely need to be really comfortable reproducing this table. Do not forget that disease status goes on top, test result goes on the side, and the positives go in the top left corner. You should also remember that sensitivity is going to be referring to people who have a disease, and specificity is going to be referring to people who do not have the disease. Likewise, positive predictive value refers to people who have a positive test result, and negative predictive value refers to people who have a negative test result. And finally, when you are deriving all of these formulas, remember, true goes on the top and the sum goes on the bottom. And that's it for diagnostic tests.